When faced with the challenge of powering a 12 volts alternating current water softener transformer from a 240 volts power source, safety and code compliance are paramount. A cheap or makeshift solution might seem appealing, but poses significant risks. A legal and safe solution involves using a step-down transformer. Firstly, purchase a 240 volts to 120 volts step-down transformer. This device reduces the voltage appropriately. Secondly, ensure the transformer has an adequate power rating for the water softener transformer. This means that the transformer should be able to handle the power demand of the water softener without overheating or failing. Thirdly, plug the water softener transformer into the step-down transformer. Then, plug the step-down transformer into the 240 volts outlet. This approach provides a safe and code-compliant way to operate the 12 volts water softener transformer from the available 240 volts power source. Another option is to use a 240 volts to 12 volts converter. Firstly, search for a commercially available 240 volts to 12 volts power converter. These converters are specifically designed to reduce voltage and can be found at electrical supply stores or online retailers. Secondly, connect the converter directly to the 240 volts power source. Ensure that the connections are secure and properly insulated. Thirdly, plug the water softener transformer into the converter's 12 volts output. This provides a direct conversion from 240 volts to 12 volts, meeting the water softener transformer's power requirements. An important step is to hire a licensed electrician to inspect the installation and ensure it complies with local electrical codes. An electrician can verify that all wiring is correct, connections are secure, and the installation meets safety standards. They can also identify any potential hazards or code violations. Avoid using cheap or makeshift solutions that could pose safety risks. These methods, while seemingly cost-effective, can lead to electrical shocks, fires, or equipment damage. It is always best to prioritize safety and use approved and reliable methods for voltage conversion. Auto transformers are sometimes considered as a solution. Firstly, an auto transformer can provide a 120 volts output from a 240 volt source. However, this is not considered a safe or code-compliant solution in many jurisdictions. Secondly, it requires specific wiring and should only be installed by a qualified electrician if permitted by local codes. Thirdly, auto transformers lack the isolation between the primary and secondary windings found in step-down transformers, which increases the risk of electrical shock. Another method is placing an incandescent lamp in series with a water softener transformer can reduce the voltage. However, this is a very inefficient and unreliable method. The lamp's resistance changes with temperature, leading to inconsistent voltage output. This method is not recommended due to its inefficiency and lack of safety. When dealing with electrical installations, always prioritize safety and compliance with local electrical codes. If you are unsure about any aspect of the installation, consult a licensed electrician for assistance. They can provide guidance and ensure that the installation is safe, code compliant, and reliable. The NEC, or National Electrical Code, provides guidelines for electrical installations. When working with transformers and converters, it's important to consult relevant sections of the NEC to ensure compliance. For example, NEC Section 450 covers transformers, including installation requirements and safety precautions. NEC Section 430 covers motors, motor circuits, and controllers, which may be relevant if the water softener includes a motor. Some things to note in the NEC are firstly, NEC 110.3b requires that all equipment be installed and used in accordance with the manufacturer's instructions. This means following the manufacturer's recommendations for wiring, grounding, and overcurrent protection. Secondly, NEC 210.8 specifies ground fault circuit interrupter, or GFCI, protection for receptacles in certain locations, such as bathrooms, kitchens, and outdoor areas. If the 240 volts outlet is located in one of these areas, it should be GFCI protected. Thirdly, NEC 250 covers grounding and bonding requirements. Proper grounding is essential for electrical safety and helps to prevent electrical shock. When selecting a step-down transformer or power converter, consider the following factors. Firstly, voltage rating. Ensure that the transformer or converter is compatible with the input voltage of 240 volts and the output voltage of 120 volts or 12 volts. Secondly, power rating. Select a transformer or a converter with a power rating that is sufficient for the water softener transformer. The power rating is typically expressed in voltamps or VAR. Thirdly, safety certifications. Look for transformers or converters that have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or Canadian Standards Association, or CSA. These certifications indicate that the product meets safety standards. Fourthly, efficiency. Consider the efficiency of the transformer or converter. A more efficient device will consume less energy and generate less heat. Fifthly, size and weight. Choose a transformer or converter that is appropriately sized for the available space and is easy to handle. Sixthly, warranty. Check the warranty offered by the manufacturer. A longer warranty indicates greater confidence in the product's reliability. When installing the step-down transformer or power converter, follow these steps. Firstly, turn off the power to the circuit at the circuit breaker. This is essential for safety. Secondly, identify the 240 volts outlet. Ensure that it is properly wired and grounded. Thirdly, connect the input wires of the transformer or converter to the 240 volts outlet. Use appropriately sized wire connectors and ensure that the connections are secure. Fourthly, connect the output wires of the transformer or converter to the water softener transformer. Again, use appropriately sized wire connectors and ensure that the connections are secure. Fifthly, ground the transformer or converter. Connect the grounding wire to a suitable grounding point, such as a metal enclosure or a grounding electrode. Sixthly, turn on the power to the circuit at the circuit breaker. Check the voltage at the output of the transformer or converter to ensure that it is correct. Seventhly, test the water softener transformer to ensure that it is operating properly. Monitor the transformer and converter for any signs of overheating or malfunction. If you notice any problems, turn off the power immediately and consult a qualified electrician. Overcurrent protection is an important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the requirements for overcurrent protection in various sections. For example, NEC Section 240 covers overcurrent protection in general, including the selection and installation of circuit breakers and fuses. When selecting an overcurrent protection device, consider the following factors. Firstly, ampere rating. Select a circuit breaker or fuse with an ampere rating that is appropriate for the circuit. The ampere rating should be based on the ampacity of the wires in the circuit and the load connected to the circuit. Secondly, interrupting rating. Ensure that the circuit breaker or fuse has an adequate interrupting rating. The interrupting rating is the maximum current that the device can safely interrupt without failing. Thirdly, type. Choose the appropriate type of circuit breaker or fuse for the application. There are several types of circuit breakers and fuses available, each with its own characteristics and applications. When installing an overcurrent protection device, follow these steps. Firstly, turn off the power to the circuit at the main circuit breaker. Secondly, install the circuit breaker or fuse in the appropriate location in the electrical panel. Thirdly, connect the wires of the circuit to the circuit breaker or fuse. Fourthly, turn on the power to the circuit at the main circuit breaker. Fifthly, test the circuit breaker or fuse to ensure that it is operating properly. Regularly inspect the electrical installation for any signs of damage or deterioration. Look for things such as cracked or broken wires, loose connections, and corroded terminals. If you notice any problems, repair them promptly. Also, periodically test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect against electrical shock and should be tested monthly. To test a GFCI, press the test button on the device. The GFCI should trip, interrupting the power to the circuit. To reset the GFCI, press the reset button. If the GFCI does not trip when the test button is pressed, it may be defective and should be replaced. Remember, electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, hire a licensed electrician for assistance.